Okay, hello friends. So welcome you all again in this video. In this video, we will see the energy stored in magnetic field and the energy stored per unit volume, their expression. So energy stored in magnetic field. Let us consider this simple solenoid to understand this concept. The solenoid is nothing but the number of turns of the coil which are wounded on the core. And as soon as we give supply to the coil, it produces magnetic field around it. So this is called a simple self solenoid. So we can consider this solenoid to understand energy stored in the magnetic field. Now as soon as we give supply to the to the coil, it produces a magnetic field. And here is a key: if we on and off this circuit, there will be a changing magnetic field. So due to that, to the surrounding of this coil, there will be increasing or decreasing effect of the magnetic field. So here in the coil, there will be a storage of energy in terms of the magnetic field. Just like when we connect a capacitor across the source, the capacitor charges. That means it stores energy in terms of electrostatic field. And when we remove the battery, the capacitor itself store charges which will keep in that until we connect any external resistor or we'll just short the capacitor, right? So similarly in this case of the magnetic circuit also, when we give supply, the coil is magnetizes. That means the energy is storing in terms of magnetic field. And as soon as we connect an external load or the short circuit the terminals, the energy is still stored in the coil itself. So this is what the process of energy storing in the magnetic field. When we connect a battery to the coil will produce a magnetic field. And as I said, the concept of residual magnetism, if we remove this battery, uh, until the residual magnetism is present in this coil. So this we can call as the energy stored in the magnetic field. Now when we connect an external load or short circuit that terminals of the solenoid, the energy is quickly collapses. So this collapsing magnetic field will show that the magnetism is ending inside the coil. So this is what the process of the energy taking back. So we can say whenever the capacitor is connected to the resistor, the capacitor discharges. So similar in this case. So here in solenoid, when we give supply, energy is stored in terms of magnetic field, and when we connect the external load, then a magnetic field collapses. Now this induced EMF in the coil due to the self induction is given by, as we have seen in the previous video, E is equal to minus L di by dt. This is what the self induced EMF in the coil itself, right? So when we give supply, it will set up a magnetic field, and due to that magnetic field, it will set up an EMF, and this EMF is exactly opposite to the source voltage. That's why the negative sign is given to this formula. So E is equal to minus L di by dt, where L is the self induction. So the expression for energy stored in magnetic field, let us see the expression so that we will understand how to calculate this energy stored in the magnetic field. If the current flowing through the coil is increased by di in dt second, the self-induced EMF in the coil is given by this formula. E is equal to minus L di by dt. This EMF opposes the rise in current. Look at that. This is the self-induced EMF which is exactly opposite to the source voltage. So this will oppose the EMF and this EMF will oppose the rise in current. Right? This is due to Lenz's law. Lenz's law says that the cause which is producing the EMF, the current will set up and which will oppose the basic cause for producing that EMF. So this is what according to Lenz's law, the negative sign applies to the induced EMF. Amount of the source voltage to overcome this induced EMF, that will be negative of the self-induced EMF. So V is equal to minus E. So this much voltage has to supply to oppose this effect, right? So that's why the energy supplied by source and this stored by coil during time dt is given by energy is equal to power into time. So power here is the electrical energy, so V into I, and time is dt. But we have V is equal to minus E, then use it here in the energy stored, that is given by Vi dt. So E is equal to minus E I dt, and we have E is equal to minus L di by dt. So put in above equation, so we will get E is equal to L di by dt into I dt, and therefore this dt will get cancelled. So L di into I joules. So this is the energy stored when current changes is only di. But actually the current changes from 0 to I for the complete change in the current. Hence, to obtain the corresponding energy stored, we will integrate above equation. So total energy is given by E is equal to integration of 0 to I Li di. So take the integration of this term. So we will get L I square by 2 0 to I. So putting upper and lower limits, so we will get L by 2 I square minus 0, and rearranging it we will get E is equal to half Li square. So energy is measured in terms of joule. So this is what the energy stored in the magnetic field. So we can calculate the energy stored by this formula. So we simply should know the value of inductance L and the current flowing through the coil I. So if we know these two values, we can simply calculate the energy stored in the magnetic field. So now we'll see the expression for energy stored per unit volume. As we know, energy stored E is equal to half Li square. Substituting L is equal to N phi by I, the basic definition of self-inductance, in the above equation. So we'll get E is equal to half N phi by I into I square. I square I will get cancelled. 1 I will get cancelled. So that is equal to half N I phi. We know the MMF, which is given by N into I, and for another way it is magnetic field intensity into length, H into L, and flux density is flux per unit area. So flux is equal to flux density into area, that is B into A. Use in the above equation, so we will get E is equal to half H into L into B into A. Right? Again, from this equation we can say L into A, which is a volume of magnetic field. Length into area, it is nothing but the volume. Then here it is a volume of magnetic field in meter cube. Hence the energy stored per unit volume, which is given by the formula for the energy is given by E is equal to half H B into V. Here this small v, which is a volume. So this energy is given by joules per meter cube. So here it should be joules meter cube, because here multiplication of V. In the next step we will divide volume to the energy. Again we have the relation between flux density and field intensity, which is equal to V is equal to mu H, where mu is the permeability. So we will get energy stored per unit volume, which is equal to half mu into H square. So different forms of it. Now we'll see energy per unit volume, which is equal to half V square by mu, by using this expression again, measured in joule per meter cube in a medium, and where mu is equal to mu 0 mu r with respect to the permeability of free space and relative permeability. If for air, mu r is equal to 1, hence this equation becomes energy per unit volume is equal to half V square by mu 0. So this is for air or vacuum. So this is the complete expression for the energy stored per unit volume. So hope you understood this expression. So that's all about this. So here are the references. All I use it for making this presentation for electromagnetism.